Okay, how to calculate the time of ascent? Consider a particle which is thrown up. Initial velocity is u. Assume that it travels a distance h before coming to rest momentarily. The time taken for this journey is known as time of ascent. And you know that at the highest position the instantaneous velocity is 0. Particle comes to rest momentarily before it starts moving downwards. The equation for time of ascent can be obtained by two different methods. Method 1. I will use the first equation of motion, v is equal to u plus at. V is 0, u plus minus g into t. So, I have t from this equation as u divided by g. So, time of ascent can be written as t is equal to u divided by g. This equation can also be written in a slightly different way. Let us see how. I will consider the second approach. Observe that I can also write v square is equal to u square plus 2as. So, v is 0, this is u square plus 2 minus g into h. That gives me h is equal to u square divided by 2g. Now, what am I going to do? I am going to substitute this equation here. 2g remains in the denominator, u square is t square into g square, because from this equation t is equal to u by g, therefore, u is g into t. And here one set of g cancels. So, what do I have? I have h is equal to t square g divided by 2, or t square is equal to 2h divided by g, or t is equal to square root of 2h divided by g. Therefore, the time of ascent is root of 2h by g, or this can also be written as u divided by g. So, now what is time of descent? The time taken by the body which is thrown up to reach the maximum height is time of ascent. Time of descent is just opposite. Particle has gone up and it has reached the highest position. Now, it is coming back. The time taken for this part of the journey, the second part of the journey, is what is called as time of descent. To do this one, let us consider the following argument. Now, for the second part of the journey, the motion begins with 0 velocity. It has gone to the highest position. So, it is as good as a body which is dropped, and it covers a displacement h in the downward direction. So, I will consider again the second equation of motion. What is that? S is equal to ut plus half at square minus h. Why? Because it is in the downward direction. U is 0 plus half minus g into t square, or we have t is equal to root of 2h divided by g. So, time of descent is square root of 2h divided by g. Now, this can also be written in what form? We can also write it as u divided by g, isn't it? This can also be written as u divided by g from the previous argument.